Right, in this last video for Chapter 3, Section 3, we're going to go from grams to atoms or molecules, and then we're going to go back the other way, atoms or molecules, back to grams. If you're using this mole roadmap, if they give you the number in grams, you're going to start here, and you're going to use your molar mass to calculate moles. And then you're going to use this 6.022 times 10 to the 23rd atoms. This value is called Avogadro's number to get to your number of atoms of an element. If they give you the number in atoms and you're trying to get grams, then you're going to follow it and go in the opposite direction. But I'm going to explain it to you without having to use this. One thing that we need to talk about before we talk about how to do these problems is Avogadro's number. Avogadro did not come up with this number. It was actually named in honor of him. Some of his work led up to the discovery of this value. But we know that in 1 mole of any substance, it has 6.02 times 10 to the 23rd particles in it. We say the word particles because if we're talking about an element, then we're going to use the unit of atoms. And if we're talking about a compound, we're going to use the term molecule. So the word particles can be substituted with one of these. It can also be used for something called formula units, and that's just units that we use so that we don't have to differentiate if it's an element or a compound. So if it's just some imaginary substance and we want to calculate whatever it is, we can just put formula units on there. All right, so this is what you need to have memorized. 1 mole equals 6.02 times 10 to the 23rd. Your book carries it further out to the decimal. All you need to worry about is 6.02 times 10 to the 23rd. All right, so now let's look at a couple of problems. All right, so it says, how many formula units are there in 32 grams of FeF3? All right, sorry, I had to stop for the bell. All right, so in number 1, we're going to take our 32 grams of FeF3, and we want to convert it to formula units. Well, formula units, we're going to go back to this number, this Avogadro's number. We're still going to start with the number they gave us. So 32 grams FeF3. Right? We have units of grams. So you need to ask yourself, where can I find other values for grams for FeF3? The only answer for that is the periodic table. So if you add up the mass of iron and 3 fluorine, you should get 125.8. I'm sorry, 0.85. So then you have to figure out where you're going to put that, on the top or the bottom. Well, it's 125.85 grams per mole. I have grams here. I need grams down here. So that's where we put our 112.85, I'll get it right, on the bottom, and we put our 1 mole FeF3 on top. Now, the question doesn't ask for our answer in moles like the last sheet. It asks for formula units. So we can't stop. We have to do another step. But we do know our grams cancel. All right, so what do we know about moles and formula units? That's what you should be thinking. What relationship do I know about these? Well, I can go back here. 1 mole is 6.02 times 10 to the 23rd. I've got moles of FeF3 here. I need moles down here. So I'm going to put 1 mole of FeF3 on the bottom. And I'm going to point 6.02 times 10 to the 23rd formula units. Don't abbreviate that because it'll look ugly. Put that on top. Moles cancel out. So now, since we have same units at the end that they're asking for in the question. We can get out our calculators, and you're going to do 32 times 6.02 times 10 to the 23rd and get an answer. If you're using a TI 30, make sure that you put the 6.02 times 10 to the 23rd in parentheses. Once you get that answer, then divide it by 112.85, and you should get 1.71 formula units for FE F3. All right, so now follow the same steps, and I want you to do problem number 2. I want you to pause the video and work it out on your own, and then come back and check it. Right, so you should have gotten 1.91 times 10 to the 24th formula units for Na2SO4. All right, number 3, I'm going to work with you because we're going to start out with atoms and we're going to end up with grams. So now we're kind of working backwards. So we're still going to start with the number that they give us. All right, so we have units of atoms here. We need units of atoms down here so that they cancel out. Well, what relationship do I know about atoms? Well, I know if we have atoms, we're talking about elements, but that doesn't give me any numbers. But I do know that 1 mole has 6.02 times 10 to the 23rd atoms. So I can substitute this word atoms for particles. Since I have atoms on top here, I'm going to put my 6.02 times 10 to the 23rd on bottom. All right, so my unit of atoms cancel out. Right now I'm left with moles. It doesn't ask for moles. It asks for grams. So because I don't have a matching unit here and in my question, I know I need another box. All right, so you should ask yourself, what do I know about moles and grams? Well, anytime you're doing this and you need something for grams, automatically go to the periodic table. So look up the mass on the periodic table for silver. It's 107.87 grams per mole. So you need to decide where are you going to put your 107.87. Their units are grams per 1 mole. You have moles here. You need moles down here so it'll cancel out. So I'm going to put 1 mole of Ag on bottom, and I'm going to put 107.87 grams of Ag on top. So now my units in my last box match the units in the question, so I can stop. So in your calculator, you're going to multiply 5.3 times 10 to the 24th, and remember you might need to put this in parentheses. Multiply it by 107.87 and get an answer. Divide that answer by 6.02 times 10 to the 23rd, and again you might need parentheses. You should get 949.69 grams of Ag. If you cannot get this value in your calculator, come see me and I will help you out.